Welcome to Lecture 2, Thinking Like an Economist. This obviously is not a task you can accomplish in one lecture. However, let's introduce you to the idea. Thinking like an economist. So this section will answer a few questions. First, we'll look at the two roles economists play. We'll look at different models and how economists use them. We'll look at the elements of the circular flow diagram and the production possibilities frontier. So let's think of the economist as a scientist. So as a scientist, economists try to explain the world, and their second role as policy advisors is where you try to improve the world. In the first, economists employ the scientific method, the dispassionate development and testing of theories about how the world works. As a scientist, economists make positive statements. A positive statement is a form of analysis that seeks to understand the way things are and why they are that way. This is where you do extensive research in order to try to understand a concept and explain it. As policy advisors, economists make normative statements. A normative statement is a form of analysis that seeks to understand the way things should be. So in this job, economists will give information to our lawmakers, informing new policies, and their role is particularly useful in the assessment of cost and benefit analysis, and also into the concept of the results of policy that can be unintended. We'll have quite a bit of a look at this in a later chapter. So positive statements can be refuted and or confirmed. Normative statements cannot because they are basically subjective. One person may believe that the economy should be a certain way and others may not. So take, for example, our COVID-19 experience. Some policymakers want to make masks mandatory while others do not want to, and they say people should have the right to choose. So that type of assessment is a normative statement. So assumptions and models. Assumptions simplify the complex world and they make it easier to understand. These may sometimes be unrealistic, but simple to learn and give useful insights about the real world. So for example, to study international trade, we assume there's two countries and that they trade two goods. A model is a highly simplified representation of a more complicated reality, and economists use models to study economic issues. So, in order to show you how models work really well, let's look at have a look at some familiar models, like a globe, which is basically a model of the world, a human anatomy model. Everyone doesn't fit exactly the same way, but it gives us a good idea. Model airplanes. Once again, it doesn't function like an airplane, but when you look at it, you have an idea of how that would work. Let's start with our first model, and this is the circular flow diagram. The circular flow diagram is a visual model of the economy that shows how dollars and goods flow through markets among households and firms. Our assumptions. We have two actors, households and firms, and we have two markets. The market for goods and services like supermarkets, Target, etc., and the market for factors of production. This is a little bit more abstract, but this is where firms hire labor, they buy land and purchase capital, etc. The assumption underlying all economic models is the optimization assumption that we have mentioned before. And this is the assumption that individuals maximize their utility and firms strive to maximize profit. Some defining parameters. Households own the factors of production, which we'll define in a second, and sell and rent them to firms for income. Households buy and consume goods and services. Firms buy and hire factors of production and use them to produce goods and services and sell the goods and services to the households. What are the factors of production? The resources the economy uses to produce goods and services. This is the inputs. This is what it takes to produce any given good. Those inputs are broadly known as labor, land, capital, and entrepreneurial ability. So land is the natural resources, raw materials used to make goods. Labor is the people who work for those businesses as jobs. Capital are man-made things used to make other products or goods. So these are things like buildings, tools, machinery, even money. Entrepreneur is the person who starts the business and the idea. They are the ones that organize the industry and that company. So let's have a look at these pictures here. So here you have a production into the production of, I guess, wood of some sort. And initially the trees and so on here, nature, that's land. This machine that moves the timber is capital. The man observing the timber is labor. And of course the man here who is selling some sort of good is the businessman or the entrepreneur. So the circular flow model. Here we introduce firms, households, market for goods and services, and markets for production. And we start with the flow of real things. So first, households, as we said, own land, labor, capital, and they will sell into the market for factors of production. The firms will take the factors of production, and inside their firm they will convert it into goods and services. They will later sell those goods and services in the market for goods and services, and households will purchase them. So now when a household purchases a good or service, what do they give in exchange? Money. So spending flows from households to the market for goods and services. From the market, revenue flows into the firms. What revenue is made, the firm then pays wages, rent, and profit for their workers, for their land, for their capital. And finally, the households receive their money back in the form of income. So households provide the resources and input and later receive the income. Can we make this more complicated? Yes, we can. We can add government. And government, remember, will buy goods and services, will buy factors of production. Households and firms will then pay taxes into the government, so money flows in a lot of interesting ways. But we want to keep it simple in this first introduction. Our second model. We start off looking at the concept of consumption possibilities in order to illustrate the idea or quantify the idea of opportunity cost. So we make two assumptions in this case. We say you can buy two goods, and these two goods are ebooks and games at the App Store. This is a restrictive gift card. Your income is fixed. You have one resource, and it's that $50 App Store gift card. So let's have a look at how we would build all of the different consumption possibilities based on those two goods and that specific resource. So let's start here. If you spend all your money on books, how many books would you be able to purchase? Well, if each book is $10 and you have $50, you could buy 5 books. If you spend all your money on games, you would be able to purchase 10 games. Simple. Those are the two extremes. But what if you want to consume some of both? So let's start with the case where you currently are consuming 0 books and you decide that, buying 10 games is too many, so I would like to buy 1 book, and then we can think about how many games that'll allow us to buy. So $10 will be spent on the book. We will have 40 remaining on the gift card, and with that $40, with each game being $5, we can buy 8 games. So in order to buy 1 book, how many games did you give up? Well, before you bought a book, you were able to buy 10 games. Now you buy 8, so you gave up 2 books. So therefore, you must give up 2 games in order to buy 1 book. So this is our trade-off. So when you go from the point where you have 0 books to 1 book, initially you start with 10 games and you have to give up 2 in order to be able to purchase that book. That's your decision trade-off. This is a full table of all your consumption choices in that gift card. And technically, if we wanted a continuous picture, we could have things like half a book would be 9 games and so on, but that doesn't really make sense in real life. So we will just use the whole number valuations here. Notice, as you increase book consumption, what's happening to game consumption or your possibilities of buying games? Well, they are in fact shrinking. So as you buy more books, what's happening? Well, let's look at the marginal changes, right? So what's happening after every single decision? So when I decide to buy one book, what happens? Well, I must give up 2 DVDs. So what are the marginal changes? The marginal changes is I got plus 1 book, but I lost 2 games. Let's put this on XY axis. So let's plot these points. So here we have books on our y-axis, games on our x-axis. It doesn't particularly matter how you label these. This point here is going to correspond to when you use your gift card to only buy books. So with that point. The second point here is also where you buy 0 books and you buy 10 games. So that's illustrated there, the 2 extremes. And then of course you can fill in the rest of those dots and you end up with this perfect straight line. So these are all different possible choices. Here's another point, etc. The question becomes, what's the best point? How do I allocate this resource? Should I buy 5 books and 0 DVDs? 0 games? Should I buy 10 games and 0 books? What should I do? And the answer to that is basically whatever gives you the most utility. Now let's think about a different point. This is called the consumption possibilities frontier, which basically means you could technically consume anywhere along this line, this red line, and inside this region, right? This closed off area, which means you can technically consume at a point like A, where say you got 2 books and 2 games. Now, does that make sense? Well, not really, because it's inefficient. You basically have unused funds in your gift card and you're just going to leave them be. What about a point like B? Right? In this case, if our resources are fixed, then it's impossible to reach point B. Now, if I doubled the gift card for you, potentially you could reach point B, right? That would basically take your budget and move it up, right? Until eventually you would get to point B. So we can think of this consumption possibility as like a budget, your constraint, your budget constraint. Now, what if I cut the prices in half? If I reduce the price of books and DVDs, that would also shift up your possible budget. Okay, so because if prices were cut in half, so books became $5 and games became $2.50, all of a sudden the maximum number of books you could buy would be 10 and the maximum number of DVDs would be 20. So it would be like a shifting of your potential budget. The quantification of opportunity cost. Recall that the opportunity cost of one item is the lost opportunity to do or consume something else. In the context that we just went through, think of the opportunity cost of a book as the number of games you have to give up in order to purchase the book. So the way we quantify it and show it mathematically, we'd say the opportunity cost of good X is how much Y is given up divided by how much X is gained. These are marginal changes. So back to our gift card. The opportunity cost of one book, right? Remember, in order to purchase one book, you give up 2 games and you get back 1 book. So the opportunity cost of one book in terms of games is 2 games. So what about the opportunity cost of one game? Well, in order to get one book, one game, you have to give up half a book. So whenever you're looking at the opportunity cost of, say, good X, the opportunity cost of good Y will always be the reciprocal. So the opportunity cost of one game in this example is half a book. So let's think about this idea or concept of constant opportunity cost. So when you go from 0 to 1 book, you give up 2 games. When you go from 1 book to 2 book, you give up another 2 games. Notice it's very consistent. Well, why do we have this constant opportunity cost? Well, it's because our resource is basically perfectly efficient to allow us to consume both of those items. We'll talk more about this, about the other type, or the increasing opportunity cost, when we look at the production possibilities frontier. So the slope of a line is the opportunity cost in the production possibility frontier. Notice all we have to do is we have to take rise over run of our extreme values, so change in y over change in x, or change in books over change in games, and that effectively gives us the opportunity cost. So what we'll find is that the slope of the production possibility or consumption possibility frontier is the opportunity cost of the x-axis good, in which in this case is games. So the opportunity cost of one game is half a book. Our third model, the production possibility frontier. Let's make a few assumptions. There's 2 goods, computers and wheat. There's 1 resource, labor hours. And let's say this is labor that is equally productive in producing computers and wheat, which of course is a huge assumption. Let's assume the economy has 50,000 labor hours available per month in order to produce computers and wheat. So let's have a look at the numbers here. If you have 50,000 hours and you spend all of them producing computers, how many computers would we get? Well, the answer is we would get 500 computers. If we spent all our hours producing wheat, we'd end up with 5,000 tons of wheat. But remember, these are the extreme points here and here, right? It's like we said we only want computers and no wheat, or only wheat and no computers, right? That's not necessarily the best production points. Let's have a look at the full production possibilities. So based on this, what do we see happening? Well, if we decide, hey, we want to have some wheat, what we're going to do is we're going to have to allocate our 50,000 hours into different ways. So if we want to just get a little bit of wheat, let's say we take 10,000 hours away from computers. So now we're only making computers for 40,000 hours, and spend 10,000 on wheat. Well, that allows us to have 1,000 tons of wheat and 400 computers. If we keep going, we're basically reducing the amount of hours in computer work into wheat work until, of course, we get to point E, at which point all our workers are producing wheat. So here's our final production possibility table in terms of output. So here's our full graph. So point A represents the point where all our resources produce computer, and point E is the point where all our resources produce wheat. But these 2 points are interesting because, you know, we maybe want to consume some of both types of goods. So perhaps choices like C, D, and B would be better choices. Could we pick a point like here or here? Of course we can. We can pick effectively any point along this line. And also, since it's a frontier, any point inside that area. So for example, a point like point F is a viable production point, except as we saw earlier, it is a point that is inefficient. In fact, at this point, you would have unemployment in your labor force. What about point G? Well, point G is currently impossible given our resources and our, well, in this case, our man hours in order to produce these goods. So point G is impossible given resources and our technology. Can we get to point G? We can. In this case, we would have to see something like an expansion in labor hours, which would be something like an immigration boom, would shift that line out. the PPF all the way out so we can consume more of both goods. Another would be something like an improvement in technology in the production of these two goods, and or a reduction in the cost of producing these two goods would also help as well. So opportunity cost in the PPF. So the opportunity cost of an item is what you give up to obtain it, as we've already discussed. We're just going to apply it to the PPF in this case. So as discussed earlier, we know that the slope of the PPF gives us the opportunity cost of the good on the x-axis, in this case for computers. So the opportunity cost of one computer is 10 tons of wheat. And again, notice what's happening here. In order to gain 100 computers, if we start at point where we're not producing any, in order to produce 100 computers, we have to give up 1,000 units of wheat. And that per unit is 10 tons of wheat for each computer. So what is the opportunity cost of 1 ton of wheat? Well, it's always the reciprocal, which is 1/10 of a computer. Now, just like before, this had a constant opportunity cost, which again suggested that the factors of production, in this case labor, are perfectly or equally efficient in producing both goods. But what if that's not the case? Well, the other case, and the more realistic case, is the case of increasing opportunity cost, or the bow-shaped PPF. Let's have a look. So this is a society that produces beer and mountain bikes. If, let's say, we start at a point like this point here, where we're only producing beer, and let's say this country decides, well, you know, we want to produce a few mountain bikes as well. What they'll have to do is they'll shift workers out of beer and into mountain bike production. Initially, as this process occurs, they only give up a little bit of beer in order to gain a lot of mountain bikes. But if we're at a point, say here, and we give up the same amount of beer as we did earlier, we don't get that many additional mountain bikes. We'd have to decrease beer production a lot to get any kind of significant change in mountain bikes. Well, why is that happening? Well, it's happening because of specialization of labor. Some people are really good at beer production, and others are very good at mountain bike production. So initially, when everyone is producing beer, it includes the people that are good at mountain bikes and good at beer production. But as you start to move the resources over from beer to mountain bikes, initially the people that are most adept to making mountain bikes move, but eventually the best brewers will have to leave in order to produce more mountain bikes, causing the higher cost or the more loss in beer. And as you notice what's happening here, if you take the different slopes at different points along this PPF, you'll notice that the slope is getting steeper and steeper, implying that the opportunity cost for bikes is increasing. So again, if we started at a point like A and we decided to build more mountain bikes, well, initially most workers are producing beer, even the ones better suited for bikes. So we don't give up so much beer in order to get more bikes. So the opportunity cost is very little. If we go to a point like B, in order to produce more mountain bikes, some of the best brewers will be leaving and will be giving up a lot more beer. So this is what we call increasing opportunity cost. Why does this happen? The more specialized the labor, the greater the opportunity cost of shifting production from one industry to another. So the PPF is bow-shaped when different workers have different skills and different opportunity costs of producing one good in terms of the other. The PPF would also be bow-shaped when there was some resource or a mix of resource with varying opportunity costs. So think of different lands that are suited for different uses. So for example, land that's really good at producing citrus may not be very good at producing something like winter vegetables or coffee or something like that. So The last concept we're going to look at in this section is economic growth and the PPF, so how it's illustrated. So the way you illustrate economic growth in the PPF is basically, if we had two goods, Y and X, and here's some production possibility frontier for the two goods. The way we show economic growth is by an outward shift of the production possibility frontier. Now, when do these shifts occur? Well, they occur either when there's improvements in technology or an increase in any of the factors of production. So we could have an outward shift of PPF when there's increased labor, outward shift when there's increased capital, increased even entrepreneurial ability, and increased land. Later, when we talk about our chapter on economic growth, we'll talk about historically why there was such a strong urge to conquer one country or another. Predominantly was to increase the land resource in order to shift their production possibility frontier outward. We'll also talk about the extreme importance of capital investment in poor economies in how their growth patterns have taken place. You may be wondering, can the production possibility frontier shift inward? Well, yes it can. This happens in cases of natural disasters, war, and any time you get a destruction of your factors of production. Now, can we have biased growth? Biased growth is when one industry experiences technological improvement, in this case notebook computers, but the other industries do not. Now, I want you guys to notice something. In the extremes, all other goods, you can't produce any more of them, and you can definitely produce more notebook computers. But even in the intermediary, if we took a point like B1, initially at B1 we had this many all other goods and this many notebook computers. But even holding this concept constant, right? Notice just by that expansion in notebook computers, we're actually able to consume more of both of the goods. That's a little bit of a hint to one of your homework problems. So that's the end of lecture 2. Feel free to proceed to lecture 3.